Today's math puzzle is from the University of North Georgia math competition from the year 2015, and it asks us to find the maximum area of a rectangle whose area equals its perimeter. So this looks like a geometry problem on the surface, but we're going to actually have to do a little bit of calculus to find our answer. So first, let's write down what the problem gives us. It gives us that the area of a rectangle is equal to its perimeter. Now I'll go ahead and draw out our rectangle here, so that we have a reference for what we're working with. Now recall that the area of a rectangle can be calculated by multiplying the length and the width of the rectangle. So we'll call this segment here our length and this segment here our width. But then similarly, we can find the perimeter by 2 copies of the width plus 2 copies of the length. So we'll have 2w plus 2l. And now from our first equation, we can set these equal to each other. So we'll have LW equals 2W plus 2L. So now what we want to do is solve this equation for one of our two variables. I'm going to solve it for L, but you can solve it for W and you should get the exact same answer. Go ahead and let me know down in the comments if that's what you did. So we're going to move this 2L across. So we have LW minus 2L is equal to 2W. And then we're going to factor L out of this left-hand side, and we get L times W minus 2 is equal to 2W. And then dividing both sides by W minus 2 gives us L equal to 2W over W minus 2. So now what we can go ahead and do is we can plug this L back into our area equation, and that gives us area as a function of only width is equal to 2W divided by W minus 2 times W. So this 2W over W minus 2 comes from our length bit here, and then this additional W gets multiplied on the end. So that gives us area is equal to 2W squared over W minus 2. But now what we have to do, because we have area as a function of one variable W, we can take the derivative of this function with respect to W and set that equal to 0, and that will give us our maximum area. So we'll take the derivative with respect to W, and that gives us 4W times W minus 2 minus 2W squared, and that's all over W minus 2 all squared. And that's from the quotient rule. I have a video of that on the channel if you want to go check that out. I'll go ahead and leave it in the cards here. Okay, but we can simplify this a little bit, but we'll also remember that this is equal to 0 because we're finding a critical point. So we have 4W squared minus 2W squared, and then 4W minus 2 is minus 8W, and that's all over W minus 2 all squared. Remember, this is still equal to 0, so we have 2W squared minus 8W all over W minus 2 all squared, and that's equal to 0. We don't really want to worry about this bottom part. We're only looking for values of W that give us a 0 over here. So we can factor this top bit out, we can factor 2W out, and then we get W minus 4 has to be equal to 0. So we know that W either has to be 0 or 4. Okay, that gives us two values for L as well. If W is 0, that means that L is also 0. And if W is 4, that gives us 2 times 4, that's 8. Divided by 4 minus 2 is 2, so 8 divided by 2 is 4. So the two areas that we have are 0 and 16, and obviously we're looking for the maximum area, and so the maximum area with these conditions is 16. If you want to, you can check that this satisfies the second derivative test, but I'll leave that to you guys. I think this is enough for now.